So hello and welcome also from my side to the webinar with the topic how to protect your application and yourself with Optocouplers. So I'm Sarah Fogg and I'm working as a product manager in Würth Elektronik, and yesterday I'm going to make the presentation for you for this topic. So what can you expect in this webinar? So in this webinar, we will go a lot into the basics and also to develop the understanding of the optocoupler. I will show you some optocoupler types which are on the market, and I will also tell you what kind of or on which type we are focusing in this presentation. We will go through some application areas, and we will also go through some technical parameters and certificates which are really important for the optocouplers. Also, I will show you our new application note about the lifetime of optocouplers and show you the benefits of our series. And the last point, the last point of the presentation is what kind of advantages you will have with the Wurth electronic optocouplers. But let's start with the optocoupler types which are on the market. So on this slide, only a small part is visible. So we have a lot of more types on the market, but here 4 types are visible, which are most common. So how is an optocoupler constructed and what are the differences between these types? So in general, we can say that an optocoupler consists of an infrared LED. You can see it here on the input side. And on the output side, you have here many possibilities, and accordingly, these types are named. So if we have here on our output side a phototransistor, the optocoupler is called optocoupler phototransistor. Then the second type, which is on the market, is the Darlington type. And as you can see also in the schematic, the phototransistor or the Darlington has 2 transistors, and this is, and these 2 transistors provides higher gain levels because the gain of both transistors is multiplied. So photo Darlingtons are used where low frequency are required, and examples are modems or answering machines. The third type you can see on this slide is the optocoupler phototriac. It consists of 2 opposing thyristors on the output side, and here we have the main applications like the white goods or household appliances, industrial control, motor control. So also the triac type has a lot of applications. And the last type I want just or give you a rough overview is the high-speed optocoupler type. And as the name already says, these are optocouplers with high transmission rates, and they are used in computer interfaces and or fast analog digital converters. These are the main 4 types on the market. In this webinar, we will focus on the optocoupler phototransistor type. So this is the first type here. Now we can go deeper into the optocoupler structure of this phototransistor type. So in general, optocouplers are also called opto isolators, and the components consist, as I showed you also in the slide before, of an infrared LED on the input side and a light sensitive component. So in our case, the phototransistor on the output side. And as you can see in this diagram, both circuits are galvanically isolated from each other. That means we have here one circuit from the infrared LED, and the second one is here for the phototransistor, the second circuit. So that means they are galvanically isolated, and both circuits have no connection to each other. You can see it also here in this drawing, that the lead frame and the parts have no connection to each other. But these 2 components are communicating, and the communication between these 2 circuits is done by the infrared light. That means this infrared LED sends invisible light out, and the phototransistor receives the light and transfers it into a photocurrent. And this mechanism provides the complete electrical isolation. And as you can see also here in this picture, both parts, so the infrared LED and the phototransistor, is in one package and in one light-proof housing. And of course, optocoupler have also advantages over transformer or relays. Optocouplers have a very small size and it makes it easy to install. And they are also enable analog and digital signal transmission, and also they compensate for very low coupling capacities between input and output. So yeah, this is the main structure of the optocoupler. We are talking in this webinar about it. So let's continue with the function of an optocoupler, or why we use optocouplers. So we had heard that the optocoupler can be used as an isolator or separating two circuits. But there are also some other points we have to mention about the function of the optocoupler. So an optocoupler is not only used for isolation or over voltage protection of electrical system, but also for personal protection of electrical system. So if we consider how many installation or applications or devices we deal every day with, and all these devices are operated with high voltages. So if we have here no isolation or surge protection, it could be probably very dangerous. And yes, another function of an optocoupler is, yes, the isolation of electrical system that needs to communicate but have the ground at different potentials. So therefore also an optocoupler is used. And another function of it is to isolate low power control circuits from high power circuits, such as motor drive applications. So this is the main function of an optocoupler. And now I just want to present you some application areas where you can find this optocoupler. So on this slide, you can see the power supply here on this picture, and on the right side, you see here the isolated power supply, or in general, the flyback converter, the feedback loop. So where do we need the two galvanic isolated circuit? So a power supply has the task of converting an unstabilized input voltage into a constant output voltage. And they have a ferrite core transformer to achieve voltage transformation and galvanic isolation between the input and output side, but also to isolate the control loop from the mains. An optocoupler is required. So as you can see here in the schematic, we have here the optocoupler inside to isolate the control loop from the mains. So here we can put an optocoupler phototransistor type from Wurth Electronics. So optocoupler are mostly used in power supplies, or a big application area are the power supplies. But there are also some other applications. We can continue with digital signal transmission, or we have computer interfaces. They also require electrical isolation of circuits because these interconnected devices may have different ground potentials. And of course, I hope every of you has a smartphone or a notebook or tablets or like that. And the components devices has to be charged. And every time if you have a component or a device which has to be charged and has a charger, you need an optocoupler inside, that you have no electrical hazards and no over voltages in your device. These are the main application areas. But of course, to use the optocoupler in such application, they also need some requirements. So what does an user or an engineer want? So the first point is the component must be stable. So why? As I told you, the component has an important function in the system. So if the component fails or is not stable enough, the whole system can be dangerous or damaged. So this is one important requirement. The second one is, accordingly, along with the stability, the isolation must be ensured that no flashovers or over voltages occur. The third point is, or requirement, is the current transfer ratio should be high. So if two circuits are communicating with each other, a high CTR value is necessary. How the CTR value is exactly defined and how it is related to the other factors and properties, I will show you in the next slides. And the last point, and of course, every user wants wants a stable and a long lifetime of the system. So how we can guarantee this will be also shown in some slides. So yes, these are the four most important requirements. And how Wurth Elektronik can meet these requirements is demonstrated, and I will show you these information in the next slides. To give you an overview of all these parameters, I decided to show you all these parameters and information according to the series 816, 817, 814 in the DIP4 package. So I will show you all the possibility we have for the series, and we will go step by step through all these parameters. What is important for you as an information, when we are talking about optocouplers, we are not searching or talking about sizes like for LEDs. So we have maybe for LEDs the size 1206, so or 08, 05. In this case, for optocouplers, we are talking about series. This is why you can see the series in the headline. And DIP4 is the package for this optocoupler series. This means dual inline package with 4 pins. 2 pins, for the input side and 2 pins for the output side here. And yes, I will show you for this series, we have 5 different package types. The housing for all these 5 types is the same. They only differ in the lead frames and the mounting legs, as you can see here. And as you can see also on the left picture, the components are marked. They have a dot here, and the dot indicates the anode pin. So you have here the anode and cathode pin, and here on the opposite side, the collector and emitter contacts. And when you buy an optocoupler from Würth Electronics, you will see here on this picture also you have here marking. But when you're receiving the component, instead of the marking, you will see the series and the binning which you receive or ordered. So so we have 5 different package types for each series with different lead frames, and for every type we have 5 different binnings. So you can see here on the right side. CTR means current transfer ratio, and this is the transfer ratio between the output and the input signal. As you can see here, we offer totally 5 binnings from 50 to 600%. In the next slides, I will go deeper into the definition of the CTR. But in general, you can say we have 5 different package types, and for every package type, we have 5 different binnings. And so in total, we have 25 products for each series. I want to show you also some an overview and a direct comparison of the mounting types and corresponding soldering pads, which you can see here. So we offer 2 THT types, which are called standard and M type. And we also offer 3 SMT types called S, SL, and SLM type. So as I told you, they have all the same package or body, but they only differ in the lead frames, as you can see here. When we take a closer look into the S and SL type, we see they look really the same. They have also the same soldering pads, but here the difference is that the S type has a bit more space between the body and the PCB. The SL type has less space between the PCB and the body. It depends what the user or engineer wants. So this is why we offer also these two types. And for the standard type, as you can see here in this picture, there's a range of 7.62 till 9.5. So this is not a mistake for the whole pattern, or this is that the customer has the possibility to adjust the pins in the application like he want without damaging the component. So if he receives this THD standard type, he can bend the pins till this region or in this region. And yes, we offer all 5 types because every engineer has some different designs, and you have the possibility to order all of these types. Now we can start with the data sheet. Before we start, I want to say that the Wurth electronic data sheet is a little bit different from the ones on the market. We are offering a single data sheet for every part number. That means you have one data sheet for every package and for every binning. And yes, this is the first page you can see on our data sheet. It shows the package, the dimensions of the component, also with the marking point. As I said, this is the anode. Also the marking information, which are on this part. Here in our example, we have the 816 series with binning A, and also the date code is shown. Here, this was the example of the land pattern, which can be bended. And for this series 816, we have a DC schematic, which is shown here also. So we have here an LED and a phototransistor on the output side. What can also be found in our data sheet, on Wurth electronic data sheet, under this general information, you will find the type of the optocoupler. So I showed you on the first slide in the presentation the different types. And here you can see the phototransistor type. For the input, as I told you, I choose the 816 series, which is a DC type, has a DC input. In Wurth Electronics portfolio, we offer also a AC input. You can find the package name, and the optocoupler phototransistor types are offered in a white package. Of course, in the following table, you'll find all the necessary certifications for the series with the certificate numbers here inside. And in addition, also the general storage and operating temperatures are given. So let's take a deeper look into the electrical properties and how the data sheet can be read. So the first table shows you all important absolute maximum ratings for the LED, so from the input side here. So when you take only a look into a LED data sheet, you will also find some parameters like the forward current, which here has the maximum of 60 milliamps for the series. The second table shows you all important information for the detector. So in our case, the phototransistor type and the output side. And the series 816 is also characterized by the maximum collector emitter voltage of 80 volts. So this collector emitter voltage means you can apply a maximum collector emitter voltage, so a voltage from the collector contact to the emitter contact of 80 volts. And the last table shows you the component information, so of this whole component. And here we have the isolation voltage. And this is one of the most important parameters for an optocoupler, because this isolation voltage is the maximum voltage that can be applied between the input and the output pins without any breakthrough. So this is these are the absolute maximum ratings. Now we can continue with the electrical and optical transfer properties. So as I have already mentioned, the CTR value plays an important role for optocouplers, and I just want to explain you what the CTR value means. So it's defined, as you can see here on the right side. You have the output signal, which is divided by an input signal in milliamps and multiplied by 100. So IC is the output signal. So we receive from the photocurrent, or we receive from the phototransistor. And IF is the input signal of an LED. So when you take here a look at a test condition, we have here a forward voltage of 5 milliamps. That means we apply here 5 milliamps on the LED. Then the LED shines out with the light intensity. The phototransistor receives the light, and then he converted into a current, called photocurrent, and this is the IC. So we divided this current from the output with the input current and multiplied it with 100. And this is how the CTR, current transfer ratio, is defined. And yes, as you can see here in our data sheet, we have only one CTR value which is given, but we offer also 5 different CTR binnings. What is important in our data sheet, we give the CTR value with a test condition of a forward current of 5 milliamps. On the market, and there are also some data sheets with an input signal of 1 milliamp or also 10 milliamp, which are applied and specified. And to avoid any misunderstanding, the optocouplers from VE can be also operated with 1 milliamp. We specified with 5 milliamp, but I just want to make clear there's no failure. This is just given by the market or by the company how the test conditions are. Yes, and besides to the current transfer ratio, you can also see the switching times, so the rise and fall times, and the isolation resistance, and some other parameters. But let's focus on the CTR value. So since the CTR value is a significant parameter, we have to take a closer look into the diagram. So as I told you, we specify the CTR value with a forward current of 5 milliamp. This is why our relative CTR is here at 5 milliamps 1. So we apply a voltage of 5 volt here on the output side. We put a forward current of 5 milliamps and receive here the relative CTR value. So, but we have to pay attention in the circuit design because, as you know, the CTR formula is dependent also on the light intensity of the LED. So the light intensity or emission decreases over time. So when the light emission is decreasing, we will get also a lower output from the phototransistor type. So this have to be this is what have to be clear and has to be paid attention in the circuit design. The second point is, I told you you can apply the optocoupler. You can apply also 1 milliamp to your optocoupler or to your LED. But if you apply 1 milliamp on your on your LED, you will get also a lower output current of the phototransistor. That means you will also get another CTR value. So this is not a problem. You can also apply currents in this region, but you have to pay attention that the CTR value is changing. But one important point is what is also a benefit of the optocoupler of Elektronik. Of course, a lot of engineers want only to apply a lower current and drive systems with low currents. And the benefit is also if you drive your application with a low current, you will get a high CTR value. So you can drive it with 1 milliamp without any problem. So this is a big benefit because there are also optocouplers on the market which curve is under this curve, and so we keep a higher CTR value in low current operations. So in this region. The second point is, as I told to you, or one of our requirements in the beginning of the webinar was that the component must be stable. And a stable component is also characterized by the fact that it works very well at different temperatures. So here in this diagram, we cover the temperature from -55 degrees till 110 degrees. And what we can see that the temperature here is really stable over the whole temperature range. So this is also a benefit of this optocoupler series. And yeah, and this is what I want also to say, the good stability of the complete temperature range, especially also in the high temperature range, which is also sometimes required by a customer. Of course, we have here a peak in this curve, and this is why, because the efficiency of the infrared LEDs decreases with temperature. So if we get higher temperature, the infrared LED decreases, but the gain of the phototransistor increases. So therefore, we have here a peak in this curve. And as I mentioned earlier, the CTR can change based on the light intensity. And one of the requirements was that the system should not age. So therefore, we wrote an application note how you can estimate the lifetime of your optocoupler. And it can be found under this link here. So you can read the whole application note about the lifetime of optocouplers, and content of this application note are definitions and calculations of the lifetime parameters, but also which parameter let the component age faster. So we give you can read through it, and which design improvements and consideration can be made to increase the lifetime of your system. And based on different parameters, the lifetime of optocouplers was determined. So you can find also some calculation and formulas, and on which degradation parameters you can estimate the lifetime. And Würth Elektronik optocouplers have a really long lifetime of around 25 years, which is really long. But yeah, just please read through the application note. It will give you a lot of information, how you can improve your design, how you can increase your lifetime of your system, and especially of these optocouplers. Yes, the certificates. So I told you that optocouplers have an important role or task in an application. So this is why they have also be certified. And one of the most important parameter of an optocoupler is the isolation voltage I also showed you. It was for the series these 5000 volts. And the isolation voltage is determined by the package and structure. And the isolation voltage has also two important parameters which are defined. So this is the external creepage and the clearance. And the creepage is the shortest distance along the surface between input and output. So this is this area. And the clearance shows you the shortest path through air between input and output. And these parameters, and these values, and these parameters can be found in the certificates. But how you can find it? These certificates you can find on the first page in our datasheet. But how can you find now the related documents. So it's in the table you can see the file number. It's here, the 400.51484, and the suitable standard, which the optocoupler is tested. So what you can do is go on the VDE website, like this one. Just enter this file number, and you can download all important files for the certification, where you can also find the information about the insulation thickness, about the clearance, the isolation voltage, and so on. So many parameters and definitions are in these certificates. I showed to you the series 816 or the data of the 816 series, and I also presented you the DIP4 type. But with Elektronik's portfolio, we have also some other types of optocoupler for phototransistors. So we have here the SOP4 type, which is thinner, as you can see, and the LSOP4 type, which is also really thin, but yeah, like the name says, long, small outline package. It's a little bit longer than the SOP4 package. The customer or the engineer has also the opportunity to choose between an input, DC input, as you can see here, or an AC input, what you can see here in this picture, where you have two LEDs inside. And here you can see the suitable series to each package. So for the DIP4, we have the series 816, 817, and so on. And of course, I told you and I showed you the 5 different lead frame options. This is only for the DIP4 series. For SOP4 and LSOP4 series, we only have one package size, like it's here shown. How you can easily find the phototransistor product. So here you have a table with all the overviews and part number, how they start. And yeah, the different series has different input schematics, as I showed you, the DC and AC input. And also different collector emitter voltages. So here we have the possibility of 80 volts and 35 volts. And moreover, here's the different packages sizes. And now what you can also see here in this last row, we have also different isolation voltages. And these isolation voltages, they are pending on the package size, as I told you, the creepage and clearance. These values are really important for the isolation voltage, and this package has lower creepage and clearance distances. This is why the voltage is also lower. And yes, all series are available with different binning options, and all products are available like stock. So you have the opportunity to order all these components. Now I want to show you how you can easily find them on the homepage. So if you go on the Wurth Elektronik homepage, you can find these optocoupler series under the product group Optocoupler under the optoelectronic components department. And here you can see the different package types and packages, and now you have to choose, okay, what kind of packages do I want? And if you have the package, you can easily, so I choose here in this case the DIP4 package. You can see here you have the different series possibilities to choose. Then you have to choose the series. You can see here in this table all the different binning options we have, and also of course the different package types. You have the opportunity to download all the data sheets and download documents like simulations, and if you would like to order some samples, just click here on the shopping cart and order the samples. Now we are going to the last point of the webinar. What kind of advantages the optocoupler with Elektronik have. So what I just want to explain to you, you can see here the structure of this optocoupler. On the market, we have two different structures for optocoupler. One is the over and under type. And as the name suggests, the LED is located above the phototransistor. And the second type, which we can see here, is the coplanar structure. That means the LED is next to the detectors, so not above. So yeah, what is the advantage of the coplanar structure? So as you can see here in this picture, we have here a fixed isolation gap. And this gap is also really important for the isolation voltage and to have a stable CTR and a stable product. So you see with this structure, you will never get a lower distance between these two parts. And yes, because we have the coplanar structure in our portfolio, we decided to make it in a white package. And yes, this, as I told you, this fixed isolation gap is to avoid the over voltages here and flashovers. Another feature in the series is also that the Würth Elektronik is providing the optocouplers with a copper lead frame. Mostly the optocouplers are given on the market with an iron lead frame, but we decided to make it with a copper lead frame because this is more reliable. It is better for the solderability. So this is also an advantage of this optocoupler. And as I showed you in the slides before, we keep a high CTR value also in a low current operation. So if you only apply 1 milliamp, you will get also a high CTR value. And one of the requirements was also to have a stable component, and this can be guaranteed because we have a high CTR during the whole and stable CTR during high temperatures and over the whole temperature range also. And yes, all products, as I told you, are available. All package sizes are available with every binning, and all products are ex stock, so you have so you can order the items anytime, and you have no long delivery times for these components. So yeah, these were the basics on this webinar. I'm finished the presentation. So thank you for joining the webinar, how to protect your application and yourself with optocouplers. I hope this gives you a short overview, what kind of parameters are really important and how you can find the most important information in the certificates, in Wurth Elektronik data sheets, and also how to estimate and to make your systems with a really long lifetime. So now you have also the opportunity to ask questions. If you have not enough time to answer it, no worries. I will answer it after the webinar with an email. So thank you for joining this webinar. Now I'm waiting for getting any questions. Now I received one. So one question is if we also offer some design kits for optocouplers. So normally we have also for the optoelectronics department many design kits also for other parts like infrared LEDs or detectors. But at the moment we do not have design kits for the optocouplers because, as you saw in this presentation, we have a lot of binnings and lead frames possibilities. So there will be a big design kit, and of course you have the opportunity to order all these products from the website. Some additional information also from my side. So Now we wrote an application note about the lifetime of an optocoupler. And now we are working also on an application note, how to calculate all your parameters for a power supply switch and the feedback control loop.